This video is going to talk about equivalent fractions. So if we were to name each of these fractions, we would see that this has 5 parts and 3 of them are shaded, and this has 2 parts and 1 of them are shaded. And we can tell by looking at the fractions and by looking at the pictures of the fractions that 3/5 is greater than 1/2. Now, if we were to look at these fractions, I would see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces here, and 8 of them are shaded. Down here, there are only 3 pieces that make a whole. 2 of those are shaded. And I can see that 8/9 is greater because the bar extends out farther. Over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces shaded, or 12 total pieces, and there are 8 pieces shaded. I can see that over here there are 5 pieces total. 3 of them are shaded. And by just looking at which bar is farther, I can see that 8/12 is greater. Let's go ahead and look again. Now, over here, I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts total, and there are 6 of them shaded. I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts total, and there are only 1, 2, 3, 4, 5, 6 of them shaded. I can see that 6/10 is bigger than 6/12. Let's look at Sarah and her half of a pizza. Sarah had half a pizza. Tom had 1/3 of a pizza. Sarah thinks that she had more pizza than Tom. Is she right? Well, yeah, we can see that Sarah got all of this, and Tom got all of, oh my, look at the size of those pizzas. See how this half and that third look roughly the same? It's difficult to tell because they're circles, but normally you would expect 2 pizzas to come in the same size. And Sarah's pizza appears to be maybe a medium, and Tom got a large. So the fractions that we're comparing are not equivalent. When 2 fractions look different but actually show the same amount, that's when we call them equivalent. So we have a fraction right here. This fraction is 1/2. Then down here we have a fraction that is equal to it. This fraction is 3/6. Now the thing about 3/6 is that it's the same thing as 1/2. They are the same thing. How do we know that? How can we prove that? Well, there's 2 different ways that we're going to talk about right now. The first is by looking at this 1/2. And if we take this 1/2 and we break each of these pieces into thirds. So if I see the dark piece over here, and I break it into thirds, and then I have the light piece and I break that into thirds, I can see that now it's the same as the fraction below it. So what I did is I multiplied 1 times 3 and 2 times 3. So I multiplied the top and the bottom number by the same amount. I broke these pieces into thirds. I could also divide, and I could circle groups of 3 in the 6th fraction. And we can see how this becomes 1 whole shaded out of 2 circles. So if we look at these fractions and we ask, are they equivalent, we can tell really easily no. They both have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. This fraction has 6 pieces shaded, and this fraction has 8 pieces shaded. Those are not equivalent. But what if we were to go over here? Didn't lead exactly where I remembered it, but that's okay. And if we come over here and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, that's going to be 6/9 here, and this is only 3/5. We can tell that these are not equivalent fractions. 6/9 is not equivalent to 3/5. Let's take a look here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That becomes 6/9 shaded here. Over here we have 1, 2, 3, 4, 5, 6, 7, 8 out of 12. These are actually equivalent. They don't look like it at first, but they are. We can tell by either looking at the bars, or we can tell by simplifying these fractions. When I have 6/9, I can know either by looking at the picture or the more experience I get by looking at the fraction that 6 and 9 are both divisible by 3. So what I'm going to do is I'm going to divide the top and the bottom number by 3. And I'm going to get 2/3. Now, let's take a look up in the picture. Let's circle groups of 3 up here. I have a group of 3 here. I have a group of 3 here, and I have a group of 3 here. And you can see that I have 2/3 are shaded. Let's take a look over here. This is 8/12. If I simplify 8/12, it should get to the same fraction as 6/9, because I can see by looking at the picture that they are the same. So let's see what I can do to get this. I know that 8 and 12, the biggest number that goes into both 8 and 12 is 4. So I'm going to divide by 4 on both the top and the bottom. 8 divided by 4 is 2. 12 divided by 4 is 3. Let's look at the picture and see if we can do the same thing. Let's split these into groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And you can see that we still have 2/3 shaded. Let's look at these equivalent fractions. For right here, I have 1, 2, 3 out of 5 shaded, and I also have 6 out of 10 shaded. And we can tell here that if we take this 6 out of 10, we can group these up more. So I can take 6 out of 10, and I can divide it, both the 6 and the 10, by 2. 6 divided by 2 means that I will only have 3 shaded. 10 divided by 2 means that I'll have 5 total. Let's take a look by circling in the fraction. Let's split all of this. Let's go ahead and circle groups of 2. 1, 2. There's my 3 shaded. And there's my 5 total. Are these equivalent fractions? Well, just by looking at the bar, no, they're not. But I also know that if I take this 3/5, and the 2/3, neither 3/5 nor 2/3 can simplify. And if I can't simplify those, then that means that we're at the end. Like there's nothing else I can circle. Over here, now we have 2/3 and we have 6/9. So let's go ahead and take a look at that 6/9 and see if there's anything that we can adjust it by. And I know that 3 goes into both 6 and 9. So I'm going to divide 6 by 3 and divide 9 by 3. And I'm going to get 2/3, which is exactly what I get up here, which you can see. Here's the one block, the other block, and the third block. When I look here, I see that 1/2 is the same as 1, 2, 3, 4, 6/12. How do I know that? I can either look at the picture or I can look at 6 over 12 and I can say, well, what number goes into both 6 and 12? The biggest number that goes into 6 and 12 is 6. So I'm going to divide by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. Look at that. I still get 1/2. So let's go ahead and name this fraction. This fraction is going to be 3/4. Seems pretty simple. Now, with this 3/4, every piece is equal, right? Everything that's shaded or not shaded, they're all equal pieces. But if we look at this 6/7, we can see that this is not an accurate representation of 6 over 7 because the shaded pieces are smaller than the unshaded pieces. And that just wouldn't be fair if we were splitting up a candy bar. But if we were to go all the way across, we could say that 6/8 is shaded because we multiplied everything by 2. We split it in half. 3 times 2 is 6. 4 times 2 is 8. We split everything in half. So they want to break each part in half to create a pair of equivalent fractions. So we start off on A with 1/2, B is 1/3, C is 3/4. They want us to break every piece in half. So what we're going to do is we're going to multiply each of these by 2 over 2 because, there we go, because we're going to take one piece and make it 2. So if we multiply 1/2 times 2 over 2, that means we break this piece in half and we break this piece in half, and that's going to be 2 out of 4. 1 times 2 is 2, 2 times 2 is 4. We break our thirds in half each, and that means that now we have just 2 pieces shaded, 1 times 2 is 2, over 6 pieces. And it's the same thing, we're just breaking it up into smaller pieces. This 3/4, if we break everything in halves, is going to end up being 6/8. These fractions mean the same thing, they just look different. Like taking a car and changing the color on it. It's the same car underneath, just a different color. So let's go ahead and talk about what fraction is shaded right here. We can see that this is 2/3. They want us to divide the squares into 6, 9, 12, and 15 equal parts. So we're starting off with 2/3. If we want to get this 2/3 to something over 6, we're going to have to break everything in half because 3 times 2 is 6. So when we break everything in half, 2 times 2, that's going to be 4 over 6. To get everything into 9 equal parts, or a denominator of 9, we're going to multiply by 3 because each one of these pieces has to be broken into thirds. So when we multiply 2 times 3, we're going to get 6 over 9. To get it into 12 equal parts, we're going to have to multiply by, well, 3 times what is 12? 3 times 4 is 12, which means we're going to break them into fourths, which means we're going to cut it up into those perfectly equal portions. 2 times 4 is going to be 8. And then to break it up into 15, we need to multiply 3 times 5 to get 15, which means we need to cut these into fifths, which means 1, 2, 3. Those perfectly even portions mean that 2 times 5 is 10. These are all 2/3. We've just broken them up into smaller bits. 2/3, 4/6, 6/9, 8/12, 10/15. They all mean the same thing. They all mean 2/3. We're just breaking them into smaller portions. We just talked about how to do this. We just talked about what we multiplied on the top and the bottom to get those numbers. 3 times 2 is 6, so we're going to put a 2 there. 3 times 3 was 9. Notice how we're always multiplying by the same number on the top and the bottom. Very important. So they want us to divide each of these pieces into equal parts. So there are a total of 12 pieces on each of these sections, and then write equivalent fractions with multiplication statements. We've been doing that. So this first one is 2/3. Now, what do I have to multiply to go from thirds to twelfths? Well, I know that 3 times 4 is 12, which means that each one of these pieces have to be broken into fourths. So that's broken into fourths, that's broken into fourths, that's broken into fourths, which means that we're going to have 8/12. 8 of those pieces will be shaded. Over here, it's 1/4, and to get over to 12, we're going to have to multiply times 3. And if we multiply times 3 on the bottom, then we have to multiply times 3 on the top. So when we multiply all these by 3, we're going to see, wow, that's the prettiest thing you've ever seen, that there are now 3 shaded sections. And then we go over to the last one. There are 5/6 shaded. To get to 12, we want to multiply everything by 2. So which means we're going to split everything, and when we split everything, that ends up having 10 shaded pieces. That is the end of our video. If you want to take an extra look at what's here, you are welcome to. Other than that, I hope that you have a wonderful day.